Okay, so in this lesson we'll begin section 11.2, which is vectors in space. All right, so first I'm just going to go back and do some preliminary stuff about vectors in general, not just necessarily vectors in space. So bear with me if you are familiar with vectors somewhat, because I'm going to start from scratch here. So, and also in this, you have to bear with me in this lesson. This very terminology and notation heavy, because we have to introduce some terminology that we're going to use throughout the course. So first, a vector is a quantity with both a length and direction. And I'll specify in more detail what that means as we move forward. But this is just the definition of what a vector is. It's something that has both a length and a direction. Now let's talk about some examples that you all have encountered that are vectors. So a velocity vector of an object at a time t points in the object's direction of travel at time t. The length of the velocity vector gives the object's speed at time t. A force can also be represented as a vector. So these are just a couple of examples. So we'll talk about velocity vectors a little bit later in the course, and we'll talk about forces and use vectors to represent them throughout the course. So now notice I said a vector is a quantity with both a length and a direction. So this velocity vector, the length of it represents the speed of whatever the object is, and the direction of the vector the direction of vector points in the direction of travel of the object. So now we represent vectors visually using a line segment from an initial point or you'll often hear that initial point called a tail, or tail, we'll call this one the point P naught and represent its coordinates by X naught, Y naught, and Z naught. So from an initial point to a terminal point, or tip, as you'll hear it called, which we'll call P1 with coordinates X1, Y1, and Z1. This vector is denoted. So if we want to draw the vector, then what we do is we draw a line segment. And so a line segment, remember, it starts somewhere. So one part would be a point. That's just our initial point. The other part of it would be an arrow. And that's what we would call our terminal point. So that's what we call a tail and a tip, because the tip end will have the arrow on it. The tail will just have a point there. So if you want to draw a vector, you would just sketch an arrow. Now, if we want to actually just label the vector, or we want to talk about a vector, this vector will be denoted. We don't want to write all of this. So instead, our shorthand for it, this vector is denoted. So the vector from P0 to P1. And that I put over, that's a little vector hat. So there's a little arrow. Let me draw it, write it down lower so you can actually see it a little bit better. So P0 to P1. And we put a little arrow up above it. So that is a vector hat. Now, you're not going to see this in your textbook, and I'll talk about a little bit later how your textbook denotes a vector. But your textbook uses boldface, but I can't write in boldface. So when we write, we're going to use an arrow to denote that something's a vector. Then also, if we wanted to know what the actual, what are called components are, and I'll define that more explicitly a little bit later, we use these vector pointed brackets to represent that we're talking about a vector. And the vector from P0 to P1 is X1 minus X0, comma, Y1 minus Y0, comma, Z1 minus Z0. So a couple of things here that are of importance. One, the pointed bracket. Point brackets say that I'm talking about a vector and I'm not talking about a point. So, and then also the order in which these things are written. This says the vector from P0 to P1, where P0 is our initial point and P1 is our terminal point. You have to make sure that the order in which you write your components is the same order here. Otherwise, your vector will be pointing in the opposite direction. So it's somewhat counterintuitive, because the things that come first over here are all come from P1, whereas P1 is the second thing that's written over here, and vice versa. So please make sure that you keep that in mind. That is of the utmost importance, that if I give you 2 points and I say I want a vector that has a tail of P0 and a tip of P1, this is what you do. If I were to switch which one's the tail and which one's the tip, then you need to switch all of these accordingly. All right. Now the pointed brackets are where the pointed brackets indicate a vector instead of a point. All right, and we'll sketch a picture of a 3-dimensional vector that goes in line with this definition that we have here. So we need a set of coordinate axes. So our x-axis our y-axis and our z-axis. And then you can put your points wherever you want to. It doesn't really matter. So I'm going to put my point P0 right here. And it has coordinates x0, y0, and z0. And I put my point P1 right here. It has coordinates x1, y1, and z1. Now, according to the vector that we're discussing right here, it's important that we have that this is our initial point or our tail, and this is our tip. So what we're going to do is we're just going to draw a line segment from here to here. But then, because we have a line segment, I don't know if I said this earlier or not, we have our line segment, but we need to put an arrow at the end where our tip is. Because we don't want something that, and this arrow is not indicating that this goes on forever. So there's not a ray. It's a line segment with an arrow at one end of it. So a ray that would indicate this goes on forever. But remember, a vector has to have a length and a direction. So we don't want it to be going forever. This is our fixed length of that vector, and this is its direction. So that would represent, this would be our our tail, and this would be our tip, or this would be our initial point, and this would be our terminal point for that particular vector. All right, so now one key aspect that is going to be especially important to us with vectors is that vectors they differ from points in that vectors are not fixed in space. So that means that if I have some vector, we're gonna make my marker the vector. So if this is a vector, now remember, a vector, it just has to have a magnitude and a direction. So this marker has a fixed length. I can't change the length, so I don't have any problem there. But as soon as I take this marker and I turn it this way, it's a whole new vector because I changed its direction. I didn't change its length, and I've been saying magnitude as well. You'll hear me use those two words interchangeably. But as long as I maintain the same length and direction, my vector has not changed. So now I have not changed my direction. It is still pointing in the same direction. I haven't changed my length. So all of these vectors that you see right now are the exact same thing because I'm not changing the direction. But as soon as I take this and I do that, now I've changed the direction and it's not the same vector anymore, even though the length remained the same. So vectors are free to move around in space as long as you don't change their length or their direction, then it's fine. They're still pointing in this, it's still pointing in the same direction the entire time. Its length is remaining the same the entire time. So the fact that vectors can move in space as long as their length and direction don't change helps us simplify the way that we represent vectors. So we generally move their initial point to the origin, or 0, 0, 0. And that way we don't have the 2 points that we're dealing with, the tail and the tip. One of them, the initial point, is always 0, 0 with 0, which makes our life a little bit easier in representing our vector. And represent a vector by A equals the vector A1, A2, A3. where the point A1, A2, A3 is the terminal point. So now we know that our initial point is just the origin, and this point right here is the terminal point. And now if we want to talk about the vector that goes from here to here, all we have to do is put vector brackets around these coordinates, and then we have our vector. All right. Convention also is that if I'm going to talk about the vector A, I want to name, we'll normally have our vector be a lowercase letter, normally towards the beginning of the alphabet, but that's not really that present. But however you label your vector, if you're going to use a letter to label it, then the components of that vector, which are these entries in these brackets, they use the same letter, but you just put a subscript on them. All right, so the numbers, we're going to write that out, what I just was talking about. The numbers A1, A2, and A3 are the components of A. Components of the vector A, I'm sorry. So components of the vector A. Now I mentioned this a little bit earlier, but I'm going to put it in all caps here so that it doesn't get overlooked in the textbook, hopefully. So any boldface letter in your book is a vector. So that your book's not going to use the little vector hat that we use. They're going to use boldface letters, but because we can't write in boldface, we have to have some other way to denote a vector. So that's why we use the vector hat. All right, so now we have a little bit of terminology here. So what I'll do in the next video is I'll introduce some different things like how do we find the length or magnitude of a vector. So we talked about finding the distance between 2 points, but how do we find the length or magnitude of a vector? So we'll talk about that, which is similar. And then we'll talk about what are called unit vectors and some important unit vectors. So we're going to continue section 11.2 in the next video.